So f divide g, that just means take the function f, what it's equal to, and divide by the function g. So f divide g in this case is the square root of x plus 3 over x squared. And that's it. That's f divide g. G divided by f just means take the function g, divide by the function f. So it looks like this. Now the domain represents all the possible numbers that you can plug in for x without breaking any math rules. So you want to look for square rooting a negative, which is a potential problem in both of these, and you want to look for the possibility of dividing by 0, which is a possibility over here and over here. Okay, so let's do the square root of a negative possibility first. Look, we can't have an x be less than negative 3. And the way I got that is because I looked at that inside of the square root and I said that's got to be greater than or equal to 0. Because if it's not, if you've got something less than 0, then you're talking about negative 1 or negative 2, right? Those are square roots of negatives. So this needs to be positive. That's what this statement says. And if you solve that, you get x is greater than or equal to negative 3. X equals negative 3 is fine because the square root of 0 is 0. That's fine. Okay. But there's another, well, here, let's do the same thing over here. You can't square root a negative, so same condition over here. The x needs to be greater than or equal to negative 3. And now let's look for divide by 0 problems in both of them. We have a divide by 0 problem if x equals 0. And that's part of our domain that we listed over here, so we've got to make sure to exclude it. So here's how I'd state the domain for this one over here. The domain is, I'd say, bracket negative 3 comma 0. Because remember, when you state a domain, when you do things in interval notation, it's least to greatest. So negative 3 is the smallest thing possible, but I've got to stop once I get to 0 because 0 has to be excluded. And then you can jump back on that train right after 0 and go all the way to positive infinity, as big as you can think of. That's the domain. There's a divide by 0 problem over here that we haven't analyzed. X equals negative 3 can't happen, right? So instead of saying x is greater than or equal to negative 3, my domain, I'm going to say x is greater than negative 3. See the distinction? I dropped the line underneath. Instead of using a bracket, I used a parentheses. That way I exclude exactly negative 3, and I avoid that possibility of dividing by 0. So that's the domain for this one. Okay, two more. These are really similar. F divided by g and g divided by f. So f divide g is x squared over the square root of, oh, so they are a little different. This squared part I'll help you analyze. Okay, that's f divide g, and then g divide f looks like this. G is on top. It's being divided by f. Okay, we'll do the same thing. We don't want to square root a negative. Okay, so I'll set it up the same way. 1 minus x squared needs to be greater than or equal to 0, right? It needs to be positive or equal to 0. Okay? And so if you solve that inequality, subtract 1 from both sides, you get negative x squared is greater than or equal to negative 1. Divide both sides by negative 1, which means I need to flip the inequality symbol. And then to solve for a variable being squared, you can square root both sides. So you get x is less than or equal to positive or negative 1. Because when you use a square root to cancel out a squared, you got to consider both the positive and negative answers. Okay. But also when you use a square root to cancel out a squared, that's kind of like when we evaluate absolute value problems, right? There's two possibilities, that x is less than or equal to 1, or you got to flip the inequality symbol because you just added a negative sign, right? The whole reason we flip the inequality symbol is because in negative land, when you're talking about negative numbers, negative a billion is actually less than negative 1. So we have to say x is greater than or equal to negative 1 because of the negative sign that we had to add. Okay. So this, when you put both those statements together, if you're not sure what it looks like, draw a quick number line. Draw this first one, x is less than or equal to 1. So there's a dot there, it goes this way. And then draw this statement, x is greater than or equal to 1. Those meet up in between these two. So the domain here is negative 1 to 1, where those two statements meet up in between these two lines. And think about it. if you plug in any number between here, you don't get a negative, right? If you plug in 0 for x, 1 minus 0 is 1, and square root of 1 is fine. But if you try to plug something outside this interval, like negative 2, negative 2 squared is 4, 1 minus 4 is negative 3, and we'd be square rooting a negative. And look, I didn't use brackets, I used parentheses, because if you were to put in exactly negative 1, then you would be dividing by 0. Okay? But the domain for this one, same thing up here, except I can use brackets. Because it's okay to have 0 divide by something. But there's a problem, we have a divide by 0 problem available if x equals 0. So I got to do negative 1 to 0, union 0 to 1. Okay, so same interval, except the endpoints are fine on this other one because I can have 0 divide by something. But I had to exclude x equals 0. So that's the domain for this one over here. Okay. So definitely tough stuff. Just focus on that idea though. The domain, you want to avoid square rooting a negative. You want to avoid dividing by 0.